Thank you, everyone. Thanks for joining this session this afternoon. My name is Amit, and for this session, I'll be sharing my experience for migrating Snowflake to Databricks and the journey that includes migration rationale, migration planning, implementation, opportunities and solution, and I will conclude the session with lesson learned and the results. But before I delve into the details of the session, I would like to do a simple poll. How many in the audience are running Snowflake as well as Databricks or looking forward to do such a migration? So would like to flash this code. Doing more with less is new imperative. I don't think this needs any additional justification. Very well said. In the current environment where everything is about the cost and resource optimization, I think it's important. Every company right now, the environment we are in, everybody wants to do actually more with the less resources, whether it's around cost, resources. Yes. How do we productize? How do we implement or basically make AI a part of it? And yes, we will see that. So I will start with the migration rationale. So within the migration rationale, there are key considerations. So let me start with basically what was the situation. So the data team was very productive, but siloed. Analytics lived in multiple tools, and machine learning lived another pool. And collaboration suffered. So it needed more than a cloud data warehouse, which is Snowflake. It needed Unity. There was a growing ask from the data engineers, data scientists, data analysts, asking for a same environment for accelerating the delivery with a simplifying governance. That's when the Databricks became the answer, bringing all of these teams into a one platform. As the data starts growing to hundreds of terabytes, scalability becomes a concern. Databricks cloud native architecture, it scales effortlessly and allocating the resources without any manual tuning. And Databricks does support flexibility by supporting all the latest AI and ML frameworks, as well as the most commonly used, the languages used for machine learning like Python, SQL, and R. Batch and streaming workflows, they can be integrated seamlessly, enabling the rapid innovation. And the last one is the decoupling of the storage and compute. Optimize the spend with the auto scaling that eliminates the idle cost, and the resource granularity, it prevents the over provisioning. And by having one platform, which is the unified lake platform, which is the Databricks, it slashed the tooling overhead. So that was the first thing in the migration rationale, the key consideration. Other thing is about the performance benchmarks. So now imagine the use case, a data warehouse like a Snowflake platform straining under its own weight, queries lagging, throughput choking, and teams are waiting for the results. So this was the another factor actually for switching to the Databricks. The transformation began with the performance. All those, the complex workloads where the Snowflake was basically suffering, the Databricks soared, and the Databricks Spark Power Engine, along with the Delta Lake, it processed massive data set. Data analysts or the data engineers, they weren't running queries anymore. They were flying through them. Then came the throughput. So what is the database secret actually for throughput? Massive parallel processing. So it's like an adding multiple lanes actually during a high traffic time. So it handled thousands of concurrent operations effortlessly, and real-time analytics, machine learning pipelines, no longer a bottleneck, just a smooth, unimpeded flow. So, but the real game changer for this whole transformation was about the query execution time. Delta Lake's optimized storage, along with the Photons Lightning engine, I'm sure basically all of you are using that one. So those two slash the latency like anything. What used to take minutes now basically start taking seconds. With all such improvements, now the decisions can happen faster, leading to the accelerated innovation, and a data system was reborn with a faster, scalable, and a cost-efficient data platform. The teams can collaborate without friction, being on the unified platform. And this wasn't just a migration, it was a strategic leap forward. And Databricks Unified Lakehouse empowered the teams actually to build an AI-ready foundation for the future. So those were the two basically the key rationales that why basically there was a migration that we said that we are going to move away from Snowflake to Databricks. Moving over to the second thing, which is about the migration planning. So migration planning, again, has several subtopics. The first one is the architecture assessment. So let me take you behind the scenes of the Snowflake to Databricks migration journey. It began with understanding the DNA of the data, right? Meticulously mapped every table, relationship, constraints, and all the dependencies within the Snowflake, like an archaeologist, basically deciphering the script and uncovering the hidden patterns that made the data tick. So then came the data excavation, which means trying to find out how the data is flowing within the Snowflake instance, which tables being accessed most, and where the bottlenecks lurk. So all these insights, they became like a compass actually to help out how to reorganize the data within Databricks actually for maximum performance. So the final act was the architecting the future for the Databricks environment wasn't just a new home for the data, it was a powerhouse which was blending the lakehouse capability and reliability with a scalable compute. The result, it was a platform where the data ingestion, data processing, and all the advanced AI and machine learning, they started working in a perfect harmony and all with the security. It was a metamorphosis from the rigid structures that we had before to the limitless possibilities. And every decision from the schema mapping to the tool selection was a deliberate step forward towards this transformation. So continuing on this, the migration planning, second thing was about the tool selection. So let me talk about the three components that guided the migration journey. First was the schema migration tool. It was a specialized tool that was created by the team actually leveraging the open source, which was modified and it worked like a schema translator. It carefully unpacked all the Snowflake table definitions and reassembled them in the Databricks language, preserving all the relationship, data type, and what could have taken several weeks of manual effort, we were able to do that actually within days, right? And second thing is the data migration tool, a tool leveraging the dynamic duo, which is like Snowflake's copy command, and the Databricks autoloader. It orchestrated the safe passage for terabytes of the data that was stored over there and moving it actually carefully, mostly in scheduled batches, and always checking the manifest to ensure that nothing get basically lost in the transit. And finally, the metadata tool did its magic, and as all of you are familiar, the Databricks basically has got this Unity catalog. So Unity catalog became the meticulous catalog of the new system, carefully transcribing every view, functions, and all the access rule info that we used to have, everything was moved over, right? So no security permission was overlooked, no data lineage was broken. So these three components, the schema migration tool, the data migration, and the metadata mover, they became the foundation in this transformation, and together with all these components that would have been a risky leap, turned into a graceful stride into the data future. Moving on with the migration planning, the next thing was around the risk mitigation. So every time basically you do such a massive migration, you have to make sure that the risk is properly mitigated. So during this journey from Snowflake to Databricks, the top priority was clear. We need to mitigate risk while modernizing this data platform. Migration strategy was built around three core foundation pillars: incremental migration, governance, and observability, each playing a very vital role in a smooth, secure transition. So instead of doing a big bang switch, as I said before, we embraced the incremental data migration. Moving the data in a carefully validated stages helped to avoid the downtime, reduce the operational risk, and maintain the trust with the various business teams and the end users of the data. Every batch was checked for accuracy before processing, allowing to preserve the data integrity throughout the data pipeline. Governance was embedded, and of course, using with a Unity catalog, and from the day one, and with a Unity catalog, fine-grained access control tracked the data lineage and enforced compliance policy across the domain. Because this was needed actually to give a confidence that the sensitive data, so there was a lot of sensitive data actually in the Snowflake, and this helped actually to give the confidence that the sensitive data remained protected even as we were re-architecting and re-platforming this data platform. So equally important was observability, real-time insights into the pipeline performance, and then system health helped to detect issues early and act quickly on them. So team always stayed ahead of the failures, and thanks to the integrated alerting and clear visibility of this migration process, so together with these three pillars, it helped actually to reduce the risk and laid out the foundation of a resilient, governed, and a scalable analytic systems using the core Lakehouse platform. So these were the migration planning, and then obvious next step was around the implementation. So for the implementation, again, there are basically sub areas, and the very first area is data extraction. So at the beginning of this migration, it was clear that the data extraction would be a very critical phase of this. So one that will demand both the precision and agility. To balance the performance with the reliability, a hybrid extraction strategy was adopted, combining the batch processing for historical data and with the incremental loading for all the real-time changes that were occurring within the systems. This approach allowed actually to transfer massive volume using the batch approach very efficiently, and while ensuring that no data was left behind during this transition, and it also enabled a smooth, low-risk cutover without doing any service disruption. But moving the data wasn't enough. It has to be accurate. So automated validation was basically part of the process. It was implemented on every extracted file that we had. We checked for record counts, we applied checksums, we validated formats to catch the discrepancies early in the process. This not only safeguarded the downstream analytics, but also boosted the confidence of our stakeholders in the integrity of this migration. So to go further, we conducted a deep data profiling on the extracted data sets. So this helped actually with the analysis, the distribution, the surface anomalies, and then reviewing the key attributes. This all has us actually to assess the quality and informed how we would model all this transformed data onto the Databricks. So together with this extraction framework, which consists of hybrid loads, rigorous validation, and intelligent and smart profiling, gave us a transparent, high-quality data pipeline. It became the launchpad for an intelligent, governed, and an AI platform on Databricks. So the next component actually for the implementation was data loading. We just extracted all the data using those three components. Then the next thing is the data loading. For the migration process, building a robust data loading framework was a non-negotiable. It anchored on three principles: load manifest tracking, idempotent processing, and delta live tables for orchestration. So it began with a load manifest tracker and a monitoring layer. So the purpose of this load manifest was it's a system that will provide a complete transparency into the data that has been ingested, what is still pending, and where the anomalies occurred. It enabled the real-time alerts on the failed or the delayed loads and helped to respond quickly, to troubleshoot effectively, and ensure that the data is complete across the pipeline. And building an idempotent loading process for most steps, wherever basically we could do it, we did that. This meant that pipeline could safely reprocess the data without the risk of duplicating or any inconsistency. So it really helped actually because it was an essential feature when dealing with doing a retries or the changes in the upstreams and you have to do correction. So idempotent loading really helped with those things. So it preserved the data integrity while improving the resilience of the ingestion process. So to tie it all together, we adopted the delta live tables. The delta live tables orchestrated the workflow declaratively, so gained the automatic data lineage and benefited from the built-in error handling and the retries. So this dramatically reduced the operational overhead, and of course, it scaled effortlessly as the data was basically growing in size. So by integrating these three strategies, the load manifest, idempotent loading, and then delta live tables, we created a transparent, reliable, and a high-performance data loading system, forming the backbone for an advanced analytics and AI system, which is again part of your unified lakehouse platform as a backend. So next component on the implementation was pipeline refactoring. So during this migration, we saw an opportunity, and I'm sure basically if many of you are looking for migrating from Snowflake to Databricks, use this as an opportunity to go beyond a simple replication. Take a look at your full pipeline, refactor initiative, and to modernize the data flows using the Databricks native capabilities, and that's what basically we leveraged, right? So for the data ingestion, we moved to Databricks autoloader and the copy into, which gave the power to seamlessly and reliably ingest both the batch and streaming data and into the lakehouse. These tools, which are cloud native, they scale effortlessly and with the data volumes and require very minimal intervention. So this dramatically improved the reliability and they reduced the operating load. So in the transformation layer, rebuilding all the logic using PySpark and then Delta live tables, this shifted the empowering the teams to express the complex transformation declaratively. So this is basically again a change, as you may know, actually if you are using the Delta live tables on the Databricks, you can basically start expressing the transformation declaratively, and that was basically power for this particular component. This really helped actually for data lineage, quality enforcement, and simplified error handling. With the DLT, it ensured the trusted analytics-ready data while boosting the development velocity and maintainability. So for orchestration, we adopted basically the Databricks workflows and then giving a unified cloud-native interface to automate scheduling, manage dependencies, monitor jobs in the real time. So this eliminated all the fragment tooling that was basically there before and increased the visibility across the full pipeline, and by aligning these pipelines with the Databricks native services. So it unlocked the agility, scalability, and operational efficiency, building a future-ready data platform primed for AI and advanced analytics on the unified lakehouse. So the last component actually on the implementation is on the performance optimization. So during this data migration, we also turned our attention actually to unlocking the performance gain, and we did it by fine-tuning in three areas: storage layout, query engine, and cost performance equation. So first, re-architected the storage layout using the Delta Lake, and with the smart partitioning and indexing strategies, which drastically reduced the I/O overhead, and by aligning, it drastically reduced the I/O overhead and how the teams were accessing the data. They saw immediate improvements in read-write speeds, especially across very large-scale analytic workloads. And next was optimizing the query engine to fully leverage the Databricks Spark platform as well as the Photon execution engine. Refactored the pipelines and then SQL to take the advantage of features like adaptive query execution. So that was another key. Vectorized reads, strategic caching. So all this really resulted into a dramatically faster query response times and snappier dashboard, enabling the analysts and scientists to explore data with more agility. And lastly, we pursued a cost performance balance by right-sizing the compute, enabling auto-scaling, and tightening the resource monitoring. We ensured that workload ran with just the right amount of power, right amount of resources, no more, no less. And this not only optimized the performance, but cut the unnecessary spend making it an optimized spend actually on the data infrastructure. So together, these efforts transform the platform into a high performance, cost-effective environment, and it really helped actually doing the innovation at scale in a cost-efficient manner. So moving into the next area, which is about the challenges and solutions. So during this journey, there were lots of challenges in several areas, and along with each challenges, basically the solutions were identified, and that's what the challenge and solution area is about. So the first one is around the schema compatibility. I think that's what basically I mentioned before. So during the migration, one of the intricate challenges that faced was the schema compatibility, right? Navigating the differences between the two platforms means now you have to look at the data, the data types, the governance model to ensure a seamless, high integrity transition. So in this case, yes, we started looking into the data types actually across the two systems, and that's when we said that this cannot be manual. We need to use automation. We need to use some software translation, and that's when basically we took an open source, modified it, and started basically with all this data type incompatibility. For example, Snowflake, the unique variant, it needs a careful mapping to Databricks format like struct and all that. So all this was automated, DDL conversion tools and everything, it was all taken care. At the end, I would say, very few things were done manually, but majority of it was done by basically the schema translator. So the null handling was the next area. Null handling and default values, they also posed issues. Snowflake, often basically there's an implicit behavior for nulls, but Databricks require an explicit definition. So in order to address this one, we built the ETL logic that assigned clear default values and treated nulls consistently across the whole data pipeline, ensuring that there are no surprises in the downstream. And schema evolution was basically another area. So while the Snowflake allows adding the columns on the fly, and the Delta Lake or the Databricks, it is much stricter. So in order to do that, governance was implemented around the schema changes using comparison tools and Delta's native evolution features, keeping the pipeline stable and trustworthy. So constraints and keys were addressed by documents, all the relational logic, enforcing it through ETL validations and in the Databricks. With the Snowflake managed tables and views. And finally, the permissions were remapped into the Unity catalog, where it all restored RBAC, lineage tracking, audibility, ensuring that governance never skipped a bit. So that was the summary actually in the 6 areas, anything related to the schema, what were the problems, and how we basically addressed those. The second challenge is around the data consistency. So during the migration, one of the critical focus was ensuring the data consistency. So this wasn't just about moving the data, like move the data from Snowflake to Databricks. No, it was much more than that. It was moving it route. Every record, every timestamp, and every access policy had to arrive intact, and more than that, it must be trustworthy. So we began it by solving issues, the partial loads. So we use the checkpointing, load manifest tracking, could track every batch and resume or roll back when it is needed. So this approach ensured that end-to-end completeness, even in the face of unexpected failures. And next came the time spent drift. So a silent culprit in the analytical errors. So to solve this one, we enforced a standard UTC format and aligned the timestamp precision across the platform to avoid any sort of inconsistencies around the timestamp. So that helped actually during the reporting and training the data science models. So the data ordering also mattered. So without consistent sequence, the trend analysis and time-based aggregation could break. We built the order-preserving pipelines and used the Delta Lake's native support for maintaining the record sequences. So to prevent null value misrepresentation, we explicitly mapped the null value handling between the platforms, avoiding any sort of quality issues in the downstream data sets. We addressed the concurrency by leveraging Delta Lake's ACID transactions, which handled basically the parallel write safety, so which was needed. And to avoid any sort of a metadata loss that can happen, we automated the schema and lineage capture from Snowflake and restored into the Unity catalog, ensuring that governance never skip a bit. And all this using these 6 steps, using this systematic approach, it became the foundation for a trust and consistency for this migration from Snowflake to Databricks. So the next challenge area was around query rewriting. So for this migration, the rewriting SQL queries became one of the most nuanced and critical tasks. Each challenge demanded precision and approach with a very targeted, innovative solution to ensure compatibility and performance. So the first major hurdle was the SQL function compatibility. Many Snowflake specific functions, they lacked the direct compatible Databricks equivalent. In order to solve this, we created the custom UDFs and we used the LLM power translation. So again, so AI basically now being used actually to do the translation. So for this particular one, we use the LLMs actually to translate and workflows to convert and optimize queries for the Spark SQL without changing their behavior. Joins posed another challenge, and Databricks basically uses a different optimization strategy. So performance was enhanced by adding the broadcast hints and optimizing shuffle operations, dramatically improved the join speed for very large data sets. For the time handling discrepancies, as I said before, the timestamp logic is threatened the consistency. So we standardized everything on UTC and created the utility function to manage the time zone arithmetic uniformly across the platform. So Snowflake procedural logic, which basically had like store procedure, had nothing direct equivalent in Databricks. So we restructured into the Databricks notebook and Delta live tables. So this was basically one translation, another area of translation. Gaining better visibility, easier maintenance, and with the window function and subtle syntax differences, they required exact translation. So we built an automated testing framework to validate the identical behavior post-migration. And lastly, we mapped all the security policies to the Unity catalog, preserving the compliance, gaining finer access controls, and together all these 6 areas with all this effort, we delivered basically a fast, secure, and a fully functional queries on Databricks. So the summary basically in this one, I think the prime challenges were around SQL, around the joins, around the procedure, and where basically we used AI was actually do the SQL translation. So the next area of challenge was the downtime management. Of course, you are doing like a major migration. The end users, they are already using Snowflake, and when you are doing this platform modernization and you are moving, so end users should not be affected. So during the migration, highest priority was actually avoiding any sort of disruption to the business. Every challenge in that journey demanded a precise preemptive solution and was tackled with a purpose. So to reduce the data ingestion downtime, we use the parallel pipelines. So I'm sure basically you guys have used this, this sort of when you move from one system to another. So the parallel pipelines were established using the Databricks autoloader. So this dual write strategy, what it does is it let the data to flow in both systems, going into Snowflake, going into Databricks simultaneously, ensuring the business continuity without a pause. So it was built using the extensive validation and testing window with the automated comparison across the 2 platforms that they are basically exactly same. And from query results to perform the benchmark for the user acceptance testing, so that now the users can see what it takes actually on Snowflake and everything that is getting transformed on the Databricks, what are the difference. So now they can compare basically the 2 and the difference basically that this migration is making to them. So from query results to the performance benchmark and user acceptance testing, everything was thoroughly tested, ensuring the confidence in the accuracy before the final cutover. In order to do an additional assurance, we had a rollback strategy in place. So rollback strategy was again basically the key, and it has to be done very intelligently, like how do you roll back, and then once you roll back, how do you bring it to the clean state again. So that what was done, but it was needed. So after that, so the backfill and incremental load strategy combined bulk historical transfer with the change data capture to keep the data aligned and fresh through the migration was another thing that was performed. So to handle the access control changes, we face the user migration. So again, for the users, end users of the system, like all the users that were the users actually on the Snowflake, they were not like a big bang move. They were moved actually in phases. So finally, we also simplified the re-authentication through the SSO integration, enabling secure, seamless access without frustrating the users. So this new system, the Databricks Lakehouse platform, was also basically integrated with the SSO, and so the users basically they don't get frustrated. So by addressing all these 6 critical areas in a very coordinated strategy, we delivered a smooth, secure, and a transition by which basically we were able to manage the downtime and for the end users, as basically we were working on platform modernization, moving Snowflake to Databricks. So these were the areas, and now we are done. So basically we talked about migration, we talked about challenges, solutions, and now finally what the results look like. So let's look at the results. So results was around the performance gains. So for this migration, target was to look at a new level of performance gains across the entire data stack. The impact was immediate and measurable across 3 critical areas. With the Databricks Photon and Delta Lake query engine, the performance skyrocketed, delivering the query results basically 2x to 5x faster than before. And Photon's C++ vectorized engine paired with the smart caching and adaptive query execution, enabling the lightning fast analytics even on the most complex and wide data sets. Team that used to wait for minutes, now basically they were able to get their results in seconds. And by tapping into the GPU acceleration as well as the ML flow integration, again, I would like to highlight this. There is no ML flow integration actually in the Snowflake, right? So with these two, now it reduced the machine learning and ETL runtimes by up to 6 times. Data scientists, now they can iterate the model faster, track experiments effortlessly, and automate the deployment pipelines, all within the Databricks ecosystem, truly delivering on the promise of unified Lakehouse platform. It improved the productivity, shortened the time to value for every AI initiative, and Delta live tables and structured streaming. So it achieved very low latency for the real-time data pipelines, and few use cases, they used to be batched before and delayed. Now, basically during this process, we were able to turn them into real-time and responsive. So which helped actually for powering alerts, personalized user experience, and this whole Databricks migration, it turned actually performance from a bottleneck into a competitive advantage, faster queries, faster models, and real time to lots of use cases. Of course, it will be incomplete actually to not to talk about the cost reduction. So that was basically second results. During the migration, the goal wasn't just the platform modernization. It was about the unlocking real measurable impact. The results were transformative across cost operation and AI efficiency. In just 4 months, so normalized it to 12 months, the numbers basically they are here is normalized based on the 4 months. The compute cost slashed by 30% and storage expenses reduced by 25%. This came from leveraging Databricks auto-scaling cluster and Delta Lake's efficient storage formats, and cost-saving techniques like cluster right-sizing and spot instances, intelligent job orchestration, used compute only when it is needed, eliminated lot of waste, and optimizing every dollar spent on the data platform. So Databricks unified platform eliminate basically data silos. Now you don't basically need to move the data around between the various teams, and that's also basically led to a lot of cut down on the manual integration, And with the automated pipeline and job scheduling, it really helped actually to cut down the cost and reduce the operational overhead and freeing up the engineering bandwidth, allowing the teams to basically shift focus from maintenance to the innovation. So the built-in GPU support and ML flow experiments, there was a 30 to 40% reduction in the AI and ML compute cost. Data science, basically they were able to iterate faster, more efficiently scale models without over-provisioning resources, leading to better and faster outcomes. So the migration reduced cost, simplified operation, and made the AI more affordable and scalable, freeing up the resources to reinvest in the growth and innovation. So another thing on the results is enhanced analytics. Besides cost, migration was more than a platform change, more than cost saving. It was a leap forward in how to deliver value through data. It unlocked new capabilities across 3 strategic dimensions: end-to-end analytics, generative AI, and real-time intelligence. Databricks unified lakehouse. It platform transformed the collaboration, how the various teams worked, and this reduced the handoffs between the various teams, improved the data quality, accelerated the delivery, all while enforcing a consistent governing standards and access control using the Unity catalog. With a built-in support for the large language models and vector search, Databricks unified platform empowered to create AI-powered experiences previously out of reach, because the time I'm talking about, like the recent, the AI services, they were not available actually in Snowflake. So that was again a win. So making the AI analytics much faster, intuitive and inclusive for the business users. And structured and unstructured data are now unified for richer insight. So real-time decision is a reality now with robust support for streamlined pipeline. It can monitor key metrics, detect anomalies, and personalize customer experiences very quickly. So the platform handles scales effortlessly. That's another key, ensuring the low latency and analytics across a large number of events. So wanted to quickly wrap up actually with a lesson learned. So for the migration, 3 powerful lessons emerged: proof of concept, automation, and stakeholder alignment. So lot of things basically I talked about. So my advice, my guidance to all of this, start with basically very focused proof of concept. This allows actually to validate the strategy on a real workload, assess performance, and uncover the potential issues early in the process, and also give the confidence actually that the migration strategy is technically sound and also scalable to the production. And the next thing is basically quickly realize the role of the automation, and migrating large complex schemas through a manual process, I think it's not sustainable. So in order to do that, automation is needed. And the last thing is the stakeholder alignment. So when you basically plan for such a complex migration, keep the business basically updated, informed all the time about why, when, and how of the migration, so that they are not surprised. And together with these pillars, I think testing early, automating smartly, and alignment strategically, they form the foundation of a success. They helped actually de-risk the migration, accelerating the timeline, and uniting the organization. So that's the light slide. So this is about the conclusion. So this migration unlocked the unified analytics through the lakehouse architecture, breaking down silos and streamlining the collaboration between various teams. By moving to Databricks, it achieved a cost-effective, high-performance environment that scales effortlessly and empowering faster insights, better decision for a future-ready foundation to advance analytics and AI innovation. And that's it.